For the polar coordinate system, okay, the polar coordinate system, okay, the analysis of points and curves is usually done using the system called polar coordinates. Now, consider a fixed point O, 0, O. Consider a fixed point O. And this one is the fixed point O, center. Then, on line OX, point P in the plane. And we have point P, point P. Point P. Okay. Point P on the plane as shown in figure. Let R is the radius of the vector, and theta is the polar angle. This one is your theta. And these are called the polar coordinates. Polar coordinates, you have your hypotenuse and the angle theta. Okay. Cartesian coordinates, x and y. Okay. And R is the radius. Now, okay, the polar coordinates are written as R and theta. This one is your point P. Okay. Now, the polar angle is positive when measured counterclockwise. Measured counterclockwise. Counterclockwise is positive. The polar angle is positive when measured counterclockwise from OX. This one is your line. X is for the horizontal, Y for the vertical. Now, and negative when taken in opposite direction. Now, the fixed line OX is called the initial line. OX is the initial line. And the polar axis and point O is the pole of or origin. The O is the origin. Now, polar curves. Okay, we have the steps to follow in tracing the polar curves. Okay, number 1. Steps to follow in tracing the polar curves. Number 1, test for symmetry. Test for symmetry. Letter A, replace theta by negative theta. If the equation is unchanged, then the curve is symmetric with respect to OX. Again, replace theta by negative theta. If the equation is unchanged, then the curve is symmetric with respect to OX. Letter B. Replace theta by pi minus theta. If the equation is unchanged, then the curve is symmetric with respect to OY. Okay. And for letter C, okay, replace theta by pi plus theta. If the equation is unchanged, then the curve is symmetric with respect to the origin, or pole. Okay. Number 2, find the intercept point of the curve. Find the intercept points of the curve. Okay, we have theta, then 0 degrees, 0 degrees, 90 degrees, 180 degrees, 180, 180 degrees, and then 270, and then 360 degrees. Then the lower is for your R. Then number 3, find the values. Find the values of theta for which R is equal to 0, R is equal to 0, or R is equal to theta. Then number 4, study the behavior of R as theta increases through the various quadrant. And number 5, add more points if necessary.